Hello, Namaskar. So, welcome to a new video of Maths 2. From today, we are going to start a new segment of Maths 2. Okay, and now we are going to talk about systems of linear equations. Okay, equations in three variables and so on. Okay, so let's move toward our topic. The first topic is system of linear equations. Okay, so before moving to system of linear equation, let's see once again what is the equation. Okay, so a linear equation is an equation of the form a1 x1 a2 x2 plus up to xn xn equals to v, where x1 x2 and xn are the variables or unknowns. Okay, variables, you know very well what is the variables, and a1 a2 an are the coefficient. Okay, or also sometimes in some cases they are constants, but they are the coefficients which are real numbers. Okay, b is also a real number. Okay, so any equation is always in the form a1 x1 plus a2 x2 up to an xn equals to b. Okay, so this is known as the equation, a linear equation. Okay, now when we talk about the system, okay, when we talk about the system of a linear equation, okay, so system of a linear equation is a collection of one or more equation involving the set of variables. Okay, so this is a collection of, okay, this is what a collection. So here you can see this is what a collection. Okay, collection of one or more basically one or more linear equation is known as system of the linear equation. Okay, now let's move toward the main topic, why we are studying about the system of linear equation. Okay, so this system of linear equation has a very important role. Okay, so let's move toward our next topic, that is the vector representation of a system of linear equation. Okay, we we need to represent the system of linear equation matrix form so that it will be easy for us to solve this type of equation. Okay, as here we have three variables. Okay, three variables x y z. You can see x comma y comma z. We have three variables. Okay, so we what we will do, we will represent this equation, this system of linear equation, in the matrix form. Okay, so we can see that here this system of linear equation is in the form ax equals to b. Okay, we have seen that the equation is nothing but the a1 x1 a2 x2 is equal to b. Okay, so this is what in terms of ax equals to b. Okay, this system of linear equation where a is what, basically a is the coefficient matrix. Okay, here x is what, variable matrix, and this is what, solutions. Okay, values, b constants. Okay, so how we will represent this system of linear equation in uh, matrix form? So we will form matrix A, that is the coefficient matrix, as we will collect the coefficients of all these variables. Okay, so x, so the coefficient matrix of this system of linear equation will be 8, 12, 12. Okay, and here 8, 5, 5, and here 4, 7, 7. Okay, so this is the coefficient matrix of this system of linear equation. Okay, the variable matrix ax, basically this will be the capital X. Okay, so x will be what, x will be the variables matrix which consists of variables. So variables are x, y and z. We have three variables. Okay, and you can note that this is the 3 cross 3 matrix. Okay, and this is what, 3 cross 1 matrix, and we have the b matrix also, which is a column matrix of these. Okay, so this is what we have, the metric representation of a linear equation. Okay, the metric representation of a linear equation. What we do, we write a coefficient matrix, a variable matrix, and a constant matrix. Okay, now let's move toward our next topic, that is solution of a system of linear equation. Okay, what is the solution of the linear matlab solution of the system of linear equation. Okay, so we know that we have three types of solution. We have three types of solution: a unique solution, a infinitely many solution, and no solution. Okay, so these are basically what the solutions. How, what type of solution we can get? We can get a unique solution, a infinitely many solution, and no solution. Okay, one more thing here, we are talking about three variables. Okay, three variables. It is basically three variables, that is x comma y comma z. Okay, x comma y comma z, three variables. Okay, so the equation which forms will be of a plane. Okay, so when we have a two variables, that is we had x and y, the equation will be of a line. Okay, but when we have three variable, the equation will be of a plane. Okay, will be of a plane. Okay, so I hope this is the clear, this is clear to you, that the equation will be of a plane. Okay, so let's say this is the x comma y graph, so this is the equation of the plane. This will be the plane. This will be the plane. Okay, this thing is the plane. So in three variables, when we actually talk about the plane. Okay, so if we have unique solution, okay, if the system of linear equation basically have unique solution, that means that the two planes were intersecting at each other at a very, like, one single point. If we talk about three system of linear equation, so all the three equation will have a single uh, intersecting point. Okay, so single intersecting point. When we talk about the infinitely many solution, what we have, that we will have the both the plane will lie on the same, exactly overlapping both the planes. Okay, both the planes were overlapping. Okay, and for no solution, the both or all of the planes will be in parallel. Okay, no touching, so there will be no solutions. Okay, I hope you are clear with this thing. Okay, now let's move toward solving the system of linear equation. So we have the very first rule of solving the system of linear equation, that is the Cramer's rule. Okay, Cramer's rule. So in Cramer's rules, basically condition for this rule to solve the linear equation, we have some condition in this rule before we move toward the solving the system of linear equation, that is coefficient matrix of system of linear equation should be a square matrix. Okay, so coefficient matrix should be square matrix. Okay, square matrix is what, which rows and columns should be equal. Okay, second condition is determinant of the coefficient matrix of the system of linear equation should be non-zero. Okay, so determinant, we know how to find determinant. Okay, so coefficient matrix should be, okay, non-zero. Okay, so coefficient, that means that coefficient matrix is invertible. So invertible means of which we can find the inverse. Don't worry, we will talk about the inverse. Okay, so let's say we have a coefficient matrix A. Okay, we have something A11, A12, A13. Same, we have A21, A22, A23. Okay, A31, A32, and A33. Okay, let's say we have a coefficient matrix. We will have a X matrix. Okay, X, Y, Z, and also we will have a B matrix. Let's say B1, B2, and B3. Okay, so in Cramer's rule, what we will do, okay, we will first find the determinant of A. We will first find the determinant of A. Okay. After finding the determinant of A, what we will do, we will make a new matrix A, let's say AX1, or let's say AX. Okay. AX. What we will do, we will replace the very first column of the coefficient matrix with the B matrix. Okay. We will replace the very first column of the matrix A with the B matrix. So what will be our new matrix? This matrix will be B1, B2, B3, and all will remain same. A1, A22, A23, and so on. A13, A23, and A33. Okay. Now we will also find the determinant of this AX matrix. Okay. Same. What we will do, we will find a y matrix. In this matrix, what we will do, we will replace the second row. Okay. Second row with the B matrix. Okay. So this will be B1, B2, and B3. Okay. And this will be the same. This will be A13, this will be B23, and this will be B33. Okay. And then also we will find the determinant of this matrix. Same, in the same way we will form a AZ matrix, and also we will form a determinant of this AZ matrix. Okay. Now what we have? We have determinant of A, determinant of AX, determinant of AY, and determinant of AZ. Okay. So the solution, our solutions will be x equals to determinant of AX upon determinant of A. Okay. Same for Y. For Y, this will be determinant of AY upon determinant of A. And for Z also, we will have determinant of AZ upon determinant of A. Okay. So we will have these three solutions, that is the AX, X, Y, and Z. We will get three solutions for the system of linear equation. Okay. So this is how we will apply the Cramer's rule. You can apply this on any system of linear equation and find the solution very easily using this. Okay. Now let's move toward our next topic, that is the inverse of a matrix. Okay. Inverse of a matrix. Before moving toward the inverse of the matrix, I would like to tell you about the adjoint of the matrix. Okay. What is the adjoint of the matrix? Because we use this adjoint to find the inverse. Okay. So adjoint, before telling about the adjoint, I would like to remind you about the cofactors. Cofactors of a matrix. If you remember, what is the cofactor of a matrix? Like we have the matrix, this, let's say A11, A12, A13, same A21, A22, A23, and same A31, A32, A33. Okay. So we have the this 3 cross 3 matrix. So our coefficient cofactor of A11 is what? Basically 1 minus 1 power 1 plus 1 times this short matrix. Okay, this sum matrix A21, A23, A32, and A33. This is the C11. That is the cofactor of A11. Okay, so for finding the adjoint, what we find? We will find the cofactor matrix C. Okay, cofactor matrix C, that will be C11, C12, C13, C21, C22, C23, and so on, C31, C32, and C33. Okay, we will find this matrix, cofactor matrix, and then we will do the transpose. Okay, after finding the cofactor matrix of a matrix, okay, we will do the transpose, and that will give us the adjoint. Okay, adjoint of A, in short form we will write A dz of A. Okay, so this is how we find the adjoint of the matrix A. Okay, so after finding the adjoint of the matrix A, okay, the inverse of a matrix is nothing but inverse of a matrix, that is the A raised to the power minus 1 is nothing but the adjoint of A upon determinant of A. Okay, adjoint of A divided by determinant of A. This will give us the adjoint inverse. Okay, this will give our inverse matrix. Okay, here you can see that determinant of A is in denominator, so determinant of A, if determinant of A is 0, we will get this value as infinity. So the matrix will be invertible only and only if its determinant is not equal to 0. Okay, if determinant is not equal to 0, then only we can find the inverse of that matrix. Okay, and for finding the inverse of the matrix, what we have to find the adjoint of the matrix. And how we will find the adjoint of matrix? We will first form the cofactor matrix of A. Okay, and then we will do the transpose here, and that transpose will give us the adjoint. Okay, adjoint, and the inverse is nothing but the adjoint of A upon determinant of A, or somewhere we write that 1 upon determinant of A into adjoint of A. Okay, so this is how we will find the inverse of a matrix. Okay, now let's move to our the finding the solution of a linear equation with an invertible coefficient matrix. Okay, here we can see that here written clearly invertible coefficient matrix. Okay, invertible coefficient matrix. So let's take an example. Let's say we will take a 2 by 2 matrix. Okay, so let's say we have an equation given x1 plus 2 x2 equals to 1. Also, we will have 3x1 plus 5x2, okay, equals to 2. So we can see that we have the coefficient matrix as 1, 2, 3, 5. Okay, so this is our coefficient matrix. The variable x matrix will be nothing but the x1, x2, and B matrix is nothing but the 1 and 2. Okay, so you can see this clearly that we have this. Okay, so now we have to find the adjoint. Okay, like we have this, we know that we have ax equals to b. Okay, we have this ax equals to b, so we have to find the x. We have to find the x, and this will be nothing but b upon a. Okay, this will be nothing but b upon a, and that is also we can write that a of inverse into b. Okay, so b, if we want to find the x, okay, what we have to find? We have to find a inverse into b. Okay, so now let's take our a matrix, that is the 1 2 3 5, that is basically 1 2 3 5. So we have a matrix 1 2 3 5. Okay, 1 2 3 5. Okay, we have x matrix as x1, x2, and we have B matrix as 1 2. 1, 2. Okay. So now I'm telling you a trick to find the A inverse very easily. Okay. And we have to find the, like we have to find x equals to A inverse B, x equals to A inverse B. For finding the A inverse of a 2 cross 2 matrix. Okay. For finding the A inverse of a 2 cross 2 matrix, what we have to do? We have to, so A inverse will be nothing. Just interchange this. Okay. These two. Interchange these two. Okay. So this will be 5 and 1. Okay. And write these two as it is. Just put negative sign. Okay. So this is a short trick to find the inverse of a 2 cross 2 matrix. Okay. Remember that this is only valid for 2 cross 2 matrix. Okay. For 3 cross 3 matrix, you have to do all those whole process. Okay. For 2 cross 2 matrix, you can find this using this easily. Okay. You can find this using this easily. Okay. So this is our A inverse, and we have our matrix B as 1, 2. So for x, we have to multiply these two, minus 3, 1, and 1, 2. Okay, we can check that this is 2 cross 2 matrix and this is 2 cross 1 matrix, as number of columns of first matrix is equal to number of row of second matrix. So we can multiply these, and what we will get, we will multiply this with this. Okay, so will be 10 minus 4, and again for second row this will be have minus 3 and plus 2. Okay, we have x matrix is nothing but x1 and x2, and what we will get, we will get 6 minus 1. Okay, so here by comparing, okay, what we will get, x1 equals to 6 and x2 equals to minus 1. Okay, so this is how you, by this, following this thing, you can also find the solution of the 3 cross 3 matrix. Okay, by using the same way you can find the solution of 3 by 3 matrix. Okay, what we have to do, you have to find the inverse of a 3 cross 3 matrix, then you have to multiply with the B matrix, and then by comparing you will get the solution of all those variables. Okay, so this is it for this video. If you like this video, please do a like, share, and subscribe. Okay, thank you.